So, hello everyone. I hope you're able to see the screen. And so today we'll be discussing on introduction to service mesh. So if you ever wanted to, know just what service mesh is, or it has been on your mind for a while, like, okay, we have seen a lot of service mesh, but what it actually is, why do we need it? What are some of the key things that it tries to solve in the Kubernetes ecosystem and otherwise? So I'll try to break that down into simpler terms, and we'll make sure that I try to make the service mesh introduction simpler. So before that, yeah, just my introduction. You can reach me out on Twitter at Saiyam Pathak, and I work for Civo as Director of Technical Evangelism. And yeah, I have my YouTube channel as well. You can go check out some of the live streams that I do and some of the meetups that are organized. Yeah, all virtual as of now, but I used to organize a lot. And yeah, I'm CNCF ambassador as well. So let's begin. Want to begin with the plain microservice architecture, basically. So we all know that there has been a shift from the monolithic architecture to microservice architecture. Now, in microservice architecture, you can think like the application is broken down into chunks of microservices, and each microservice plays a important role. And on a whole, when all of these microservices connect to each other, they talk to each other. There is a complete workflow process. Just say that you are signing into a bank portal and you log in. So there is a login microservice for that, and then there's authentication microservices that authenticates your credentials, and then you visualize your account balance and some of the other things that can be another microservice. So on, you can consider like all of those pieces now are broken down into the microservices, but they are communicating with each other. Now all these communications, like let's say S1 is communicating to S2, S2 is communicating to S3. So this is a microservice architecture. uh, Earlier when the applications were small, so there was not much problem, but as and when we are talking about scale, we are growing in the terms of microservices, and even people are talking about nano services, even smaller microservices. So all these things getting into place and making it at scale, there are problems that arise. Now let's talk about those. Now, why service mesh can also be like, what are the problems that are there in the current microservice architecture? So first, obviously, is the authentication. So when you talk about a Kubernetes ecosystem, all services can talk to each other. So there is no authentication mechanism pre-built, like this service can talk to the other service, and they can talk to each other within Kubernetes. Now, obviously, as a developer, you can integrate your own authentication mechanism. That is doable, but that excludes your business logic. So you will not be focusing on actual business logic, which will be the functionality of the application. Second is the service call failure, which can also be like service A, which in the previous diagram you have seen service A, service 1 calls to service 2. Now if that fails, there has to be a retry mechanism. So now those set of mechanisms also has to be coded. So you can obviously a developer can code that, but again it's separate from the business logic. So there is a retry mechanism that you have to implement. Now again, the retry mechanism can be you are retrying how many number of times, how many retries are safe, how many retries are not safe, whether the retries will create more problems or will create more load. Sometimes that happens. And so all these things have to be coded in a logic. So you can see how the code is getting bigger and bigger for each microservices. Then is traffic splitting. Now that also becomes like, if you want to split traffic, you have a new version, or you might have heard of canary deployments. So you have to split the traffic between two services. Again, you have to have a separate business logic. You have to write a separate logic for that, which will be different from the actual application business logic. Then a certificate security for the services. So usually the services will talk on port 80, but you should be, they should be talking on the HTTPS port. Again, that is additional set of logic that has to be written by the developer. So you have now the idea, like the code is getting bigger and bigger, and the problems are getting bigger and bigger. So earlier you only had the chunk of business logic that you wanted to write, but now with the business logic, you also have to write a lot of other things, so that it's a complete secure, isolated with metrics. You have metrics, you have tracing. So yeah, tracing is very important. Now let's say the traffic is going from service A to service B, service B to service C, and service C to service D. So there's a chain of all these services. Something goes wrong, if you do not trace at which particular point the failure is happening, it is very difficult to debug when you have a lot of microservices. Also, network slowness. Now you want to see which call is actually taking more time, which microservice is actually taking more time. Then also the tracing plays a very important role. So that also, if you're not using like the service mesh kind of architecture, so that was still something which a developer has to take care of. So all these things, the cloud native ecosystem has developed over time, and there's a big, there's a layer that has been introduced, which is a service mesh layer. It is actually a layer, I would say, because it is a complete layer that will be solving all these issues without even changing the architecture of the developer. So developer won't need to change the actual architecture of their application, but still can leverage all these features. So service mesh is basically a service to service communication using Sidecar Proxy. We'll talk more about the Sidecar Proxy, what it is, how we can inject that using the config file. So every feature that is on the left hand side of your screen, which is authentication, service call failure, traffic splitting, MTLS, metrics tracing, they are configurable as a file. So you have a YAML file that where you can configure, and you can use any of the features that you want with respect to the service mesh that you are applying. So you will be getting all these benefits out of the box. So that's, I hope you get a rough picture like why we actually need a service mesh. So that's it. Now we have a lot of service meshes, but the common components in the service meshes will always be the control plane and the data plane. So the data plane will be actually the proxy, which is injected in the application that does all the heavy lifting. I will show you in the next slide what it actually does and where it actually resides in the Kubernetes ecosystem. The control plane component actually is the data plane coordination, like how the proxies are getting injected and all those things, how the service discovery, all the TLS of that, and the metrics aggregation. So control plane will be responsible for that aspect. So talk about any service mesh. You can talk about STO, Linkerd, console, and a lot more service meshes. So they'll be having basic control plane and data plane components, which will be there. And they'll be having a sidecar proxy, which will be injected into the pod. Now, obviously, the proxy also can be different based on the service mesh that you are trying to use or implement. So this is the sidecar proxy. Now this is the whole game that is getting played within the Kubernetes architecture. So you see here you have the application. So this is the app, and this is your pod. So in pod you have a container, which is your application container, which you have been running. Now what happens is service mesh will inject a sidecar proxy. Now this proxy can be Envoy, HA proxy, Linkerd proxy, so different based on different service mesh. And the proxy communicates between the services. Now earlier service 1 was directly communicating with service 2. Now service 1 will communicate to its sidecar proxy. Then from this sidecar proxy, it will go to the service 2 sidecar proxy, and then it will go to the service 2. Now this particular thing will manage all the authentication. So if there's certificate rotation, that will be taken care by the proxies. If there is metrics, that will be there. All your tracing, metrics, observability, all these things will be taken care by the sidecar proxy. So the proxy will generate the metrics. And on your side, on the developer side, when I say there are no architecture changes, so that's what I was telling you in the beginning. So you can use the power of service mesh with no architectural changes, and you can deploy it on your system as a layer where you have the control plane and the data plane. It will inject sidecar proxy into all your pods where your applications are, and it will start doing all the functionalities that you have configured while installing your service mesh. So that's pretty much it, like how the service mesh works, and how you have the control plane, data plane, and how the sidecar proxy works. So let's move to the next one. So these are the different service meshes. Obviously, there are more coming up, and I have not listed all of them. But Istio, I mean, it's a very very popular one, the most feature rich one, and on the other hand, most kind of complex one as well. So it can be used, for Kubernetes and non-Kubernetes workloads as well. Linkerd is kind of moving towards simplicity and increased performance, kind of lightweight, you can say. And yeah, it's basically built on top of Kubernetes, so it's very Kubernetes native. So you can say the cloud native thing of doing things. Then you have HashiCorp console, you have AWS app mesh, traffic mesh, which is from which is earlier used to be called mesh, but now it's traffic mesh. Then you have Kuma, then OSM, which is by Microsoft, and it is complying the SMI spec as well, which Kai will be talking about. So these are the set of different service meshes that you can use for your application, and each of them will give you all the powers that we discussed, plus or minus, but overall they will be solving the same common goal with different types of proxies that we'll also have a look at. So SMI is obviously, it will be covered by Kai, but it is kind of the API. So people are now, like, you have your other interfaces. So these are the interfaces that the service mesh, service meshes are actually implementing. So there are the interfaces, and all the service mesh are implementing that and complying to those interfaces. So let me show you the service. So this is a very good blog on service mesh comparison. It's kind of tongue twister, but yeah, service mesh comparison. So you, like, all these service meshes are given, and like how to choose them, all these things. And here's the comparison. Like I was saying, you have the service proxy, which is the sidecar proxy that gets injected as a sidecar onto your pod. So you have Istio, and then you have Linkerd uses the Linkerd proxy, and most of them uses the Envoy one. So Envoy proxy is something which is there, and widely used in most of the service mesh. But yeah, people have implemented, obviously, if you have to do something more lightweight, more kind of Kubernetes way, then you have to make some changes, and that's what people are doing with their own service mesh, and coming up with new solutions that are more lightweight and not heavy to run, and solving all those problems that were there. Also, like Kai will be coming more in the SMS spike, like how they are standardizing the whole service mesh ecosystem. And yeah, I mean, you can see all the advantages and disadvantages. Like it is highly flexible, but at the same time, Istio is also complex. So Linkerd is deeply integrated with Kubernetes, but it is more uh, for performance and usability, ease of use, and all those things. So like this, there is a good comparison that you can have a look at. But overall, the goal of this particular session was, like, you understand the concept, like why service mesh is needed, what are the basic problems that it is trying to solve, and where it is helping the developers to write only the business logic, and not the networking layer, and that is taken care by the service mesh, but whatever that you are choosing to implement for your system. So also, this is the Envoy proxy. Like, you can go through the documentation, like what the proxy actually does, and why Envoy, what all service meshes are using it, what are its features of gRPC, observability, load balancing, how it does all these cool fancy features. And yeah, it's obviously a CNCF graduated project, so it is matured enough to be used across the industry. Now coming to Civo, so you might have know, like, we have a marketplace where we can install a lot of cool applications. So we have a Linkerd application with a lot of plans, actually. So this was the first one that we did with detailed kind of plans. So you have your minimal with Jaeger, and with the dashboard, and with all of those. So I think that is pretty cool. We have mesh as well. Istio is also there. There is some work which is getting it done to fix, and but again, Istio will also be there very soon. And yeah, I think we are having service mesh, but like I showed you, there are other service mesh. So if you want to contribute some of the other service mesh, or you are using some of the other service mesh, then definitely contribute to the marketplace. It is open source, so you can contribute there, and we would love to have more service mesh, because our user base is it's community driven. So people tend to use different service mesh based on their needs. So you can have we would love to have that on the marketplace. So yep, I think that's pretty much it that I had for the service mesh. Hope you got some idea of what service mesh is, and why to use them.